how to calculate distances in Clay. This is something that I've just built for a client as a proof of concept, and I thought it was really interesting that much of this can be done actually with in-house tools in Clay. At first I experimented with APIs to calculate distances, but it can be done just with a formula. I'm also going to touch upon a few other things like how I find the two companies, but the main goal of this is how to calculate the distances. This is how the end result will look like. Based on the distance, there will be a certain snippet used. So of course, if it's like less than 100 miles or something, that's probably commuting distance. If it's more than whatever, then it's air travel time or likely air travel time, things like that. But that's really dependent on the copy the client wants to use or the best copy to use, but I'm not going to go into that too much. What I'm going to be using is native Clay enrichments for finding and enriching companies and finding contacts at those companies. I'm heavily going to use formulas, a little bit of AI and LLM, and Google Serper Search API, which is always a good idea to have in your Clay workspace. So let's jump straight into it. The workflow is built, so I'm only going to go through the individual columns without like creating them new. We start from a list of companies naturally, and because this is really about calculating distances, I'm not going to go into too many details how to start all of this, but basically enrich company, then we got these enriched cells here, normalize the domain, just a habit, I always do this when I get domains. Then the idea here is, because naturally we need two cities in order to calculate distances, and the use case here is to find certain teams that are not based in the company headquarter location. In order to do that, the find contacts at company integration allows me not only to look for certain keywords in certain places, but also to exclude things. And in this case, I wanted to exclude the headquarter location, which I have from the Enrich company. That returns me a few roles, in this case, very broad, everybody with IT on their profile. And what it also does is enrich those people, and here under latest experience, which is their current company, we see where they are based. In this case, it's Cairo, Egypt. Wonderful. So this gives us a lot of companies where people are based that have certain roles that are not the headquarter location. And the way I extract this is with a formula that says get the array in people, print all values from the key locality nested under the key latest experience. Ignore empty values so we don't have too many like weird empty output here. And this basically returns me all those cities that are caught in the net, so to say. And here there would have to be more logic in, okay, which city do we want to use? Do we want to only use the city of the head of that team or something like that, right? That has to be built based on the use case, but this would be one way to get to those cities. What I'm doing here, because we haven't built out the selection process of which city to select, I'm just going to use New York City as the location of that team. And what we are going to do next is actually we do have the name of the headquarter city, but I want that in a very specific format. And I want it as JSON in order to do more work with that. Something that really works well for me is using a cheap LLM, in that case Haiku, to do that transformation. And the reason I want that is because I need it for a Google search. And I don't want, for example, New York City, United States of America. I want New York, USA. I want London, UK, not United Kingdom. Otherwise, it can get very messy when you use that later for a Google search. This is I wouldn't say it's an absolutely necessary step, but I think it's interesting to see, because it's so cheap, how something like a haiku can actually be used for this data transformation. So to get really neat output here, because once I have this in JSON, I can, and also with a transformation, right? I don't only have it in JSON, but I also have the standard country code. So it's not Great Britain, it's not UK, it's in this case GB, it's USA, and so on and so on. This is really valuable. Here then, the formula used is get the JSON from response, which is the haiku column here, and print the city and country as, and then city, comma, country, because this gives me this super neat output of New York, USA, Philadelphia, USA, and so on and so on. Actually, I now realize, because I'm using New York hard-coded here, it doesn't make sense because it wouldn't come up in the search results. But I hope it still makes sense as the walkthrough how to calculate the distances. The next step that happens is use the LinkedIn headquarter address for the search, and just add the output, Washington, USA, and then coordinates, latitude, longitude. This is how this search is constructed. So I use the output of the headquarter, but transformed in a way that it's really neat to use for a search. And then I add coordinates, latitude, longitude. When you do that as a search, this is how that looks. It always gives this neat answer box output in Google. And this, of course, can be wonderfully used in Clay, because when you look at it, this is the search. Then this is dropped into the SERPA search, which is this API integration and referencing that search term. I have another video on how to integrate the SERPA API, but basically you create your search string, you drop it into the body text of the API, and then you get the search result. And what that returns, when we look here in the answer box, here we have the coordinates, just what we saw here. That result is returned here in answer box. That makes it really easy to extract, because I can just / to that answer box, which is here, set it answer box, and then we have the coordinates. A really, really neat way to get dependably to this output. What we need to do next is, and this is actually quite interesting, I used ChatGPT to come up with that idea that I can actually calculate it as purely as a mathematical formula. And what I need for that is to transform the coordinates in the pure form that it doesn't have the north and west and south, but really just the coordinates, so it can be used for the mathematical calculation, basically. The way I did that, and this is again one of those things that may seem complicated, but they actually aren't, because I need first the latitude, which is basically the stuff before the comma, and I need the longitude, which is basically the stuff after the comma. And that's more or less exactly what I prompted here. Get the answer and print what's before the comma. If this contains an n, only output the number. Look here, we have, this is the whole input string. I ask the formula to only output what's before the comma, and if it contains an n, then it should just output the number. If it contains an s, because then we need a minus in front of the coordinates, then it should output the number with a minus before, and also exclude the and also only output the number. I hope this makes sense. So basically, this is a relatively simple prompt that takes only the number, puts a minus in front if it's a coordinate of the southern hemisphere, and it just leaves it positive if it's a coordinate from the northern hemisphere. Once this is done, this is the output that I'm receiving, which is exactly what I want. Then actually a good way to do it is just to duplicate that column and change what needs to be changed. So in this case, what I wanted is, and print what's after the comma, if it contains a west or an east, as opposed to, actually, I think that should be an S. There we go. Caught a little mistake here. But we should be fine now with that change. No, I mixed it up. That's fine. So it's all correct like that. So basically, you need to make sure that it extracts the right part before or after the comma, and depending on what's in the string, it can change the output. For example, putting a minus in front if it's an S coordinate, a south coordinate. With that, we get the coordinates here. In this case, it's only companies on the northern hemisphere. This is why we don't have any negative values. But I tested it, I just deleted this row, and this works as well for the negative values, which is the southern hemisphere. With these coordinates, we have now the start coordinates and the end coordinates. The start coordinates are here, the LinkedIn headquarter. The end coordinates, in this case, are the coordinates for New York City. Again, this would be dynamically created once we have a logic of which city to choose, of all the cities we could choose from. But for the calculation, I think this is perfectly acceptable. And then I think the real meat and the secret here is the formula that actually calculates the distance. And again, this is a normal formula, and it goes like this. Calculate the great circle distance in miles, round to full miles between 2 points using their coordinates. The start latitude and longitude are in, and then referencing the fields I just created, LinkedIn headquarter latitude and longitude, which is just a pure number, and then also the end latitude and longitude, where in this case I used New York, but that would be, as I said, dynamically created based on whichever company we want to, whichever logic we want to use for the selection. And honestly, this creates this very fancy formula, which is a certain Haber-Sign formula or something like that. ChatGPT knows more. What I find just fascinating is that once you figure out that this can actually just be done in math, and you get the inputs right, that no external APIs or anything are needed for something like this. And this gives us the distances. When we look here, okay, this is actually New York City. Again, this is a little flaw because I'm using New York and it shouldn't even show up in the search results, but still it works. And when we look at, for example, this is probably Chicago or something. Yeah, Chicago, 712 miles away. That's rounded to the closest number. And based on that, here rounding is very simple. Just get distance and round up or down to 100ths of miles to get that really neat. Nobody would say, hey, your office is 3,465 miles away. And once you have that, you can round that. And here with the snippets, that is really get the rounded distance or the distance anyways. And then you basically lay out the conversion that you want. If it's below 301 miles, say that's a long car ride or train ride. If it's between 301 and 400, then let's say that's likely a long train ride or even a flight. This is just to illustrate that you can do these if-then conditions right by prompting it in natural language in the AI formula generator. And that's it. Basically, at the end, you have these really neat traveled snippets or snippets based on the distance, based on the coordinates which we found via Google search, separating out the actual coordinate numbers, and then plugging those into the calculation for the other formula. Hope this helps. If something was unclear, just drop a comment, reach out on LinkedIn. Happy to help. I think this is really powerful, and I was surprised, honestly, for some reason, that you can do this just with math and without a special API for this.